Hi guys. Okay, let's try this. I remember doing this problem actually when I actually did this earlier this year. I don't remember exactly how to do it, but I have an idea. I remember it was fun. Okay, so there are three circles here. We know the areas of each of the circles, and they're all congruent. We need to find the area of this square. Okay, so first off, what we want to recognize here is if we can get this diagonal here, then we can find the area of the square. Because if we have the diagonal of a square, let's call this d, we know that L squared times 2 is equal to d. So that means that the square root of d over 2 is equal to L. We know area is equal to L squared, so area is equal to square root of d over 2 squared is equal to, oh shoot, 2d squared, 2l squared is equal to d squared. So d squared, so this is d squared, so these two cancel out, is equal to d squared over 2, is equal to area. So if we can find d here, we can find area. Okay, so we know the area of the circle is 2025, so the area of the circle is equal to 2025 pi. That means that the pi r squared is equal to 2025 pi. Cancel these out, r is equal to 45. So the radius of each of these circles is 45. Now we just need to find d. So if we zoom in here, we see that this is composed of a couple different segments. There is 1, 2, 3, 4, 5, 6r. So d is equal to 6r plus 2 of these little corner areas. 2 of that. Now we just need to find that. So one thing that we could do is we can recognize, let's say we have a circle here. Let's put a square down. I was thinking we could use two radiuses, but that's not what we need. I'm thinking we could use the graph of a circle. Let's put a graph down. If we have a graph here of this circle, then we know when it intersects. Can we find the difference, the distance it intersects subtracted by this total distance? Okay, so this distance here is 45. Then we need to find this total distance. So this total distance is... Oh, okay, yeah. This total distance is 45 squared times 2 square root of that. So it's just root 2 times 45. So root 2 times 45 minus 45 is equal to this thing here. Or I guess root 2r plus 2. So 6r plus 2 times root 2r minus r. So 6r plus 2 root 2r minus 2r, so 4r plus 2 root 2r. R is equal to 45, so that means that we are left with 4 times 45, which is 180 plus 90 root 2. Then we just need to add all these together. 180 plus 90 root 2, we get 272. Let's check. Okay, I think this is a little unfair because I kinda got it wrong. I didn't look at the full answer. 272, I forgot to put it in here, d squared over 2. So let me put this, I'm going to put this in the room because I just forgot to do this step. Area is equal to d squared is, well, d is 180 plus 90 squared over 2. So we're left with, let me take 90 out because that's annoying. 90 squared times 2 plus root 2 over 2. 2 plus root 2 squared. This is just equal to, if I can take a, okay, 90 is, 90 times 90 is 8100, right? Yeah, so 8100 times 2 plus root 2 squared is just 4 plus 4 root 2 plus 2, so 6 plus 4 root 2, 6 plus 4 root 2 over 2. Just take that out of here. 8100 times 3 plus 2 root 2. 8100 times 3 would be 2, 4, 2, 4, 300, I think? Yeah. Plus 6, 1, 6, 2, 0, 0, root 2. Add these together, we get 30502. Okay, now let me check. Wrong thing. 40502, I meant. I just noticed that. Okay, 40502 is in fact correct. So I was like, I think I'm gonna count that as getting it because I just forgot to do the area part. But if I had just remembered that, then I would have gotten it. Cool. Thank you guys for watching. I will see you guys tomorrow. Goodbye.